Hello everyone, welcome to online video lecture series developed by Jawaharlal Nehru Technological University Kakinada in association with Andhra Pradesh State Council of Higher Education. This is Dr. M. Prem Kumar, working as professor in the Department of Electronics and Communication Engineering, Sri Vishnu Engineering College for Women, Bhimavaram.
So welcome to online video lecture series. In this lecture, I am going to discuss about cross correlation and its properties for power signals. We will discuss properties of cross correlation of power signals. So R12 of tau will be equal to limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x1 of t and x2 star of t plus tau dt. Or we can say this is R12 of tau. A similar effect can be obtained by considering the limit t tends to infinity 1 by t integral minus t by 2 to t by 2. This is x1 of t minus tau into x2 star of t dt. First property, R12 of tau 2 of tau is equal to R21 star of minus tau, which is nothing but cross correlation function R12 of tau exhibits conjugation symmetry. Let me take this equation. So R12 of tau is equal to limit t tends to infinity 1 by t integral minus t by 2 to t by 2 is f1 of t f2 star of t plus tau dt. Now taking the complex conjugate side, so limit t tends to infinity, this is 1 by t integral minus t by 2 to t by 2. So f1 of t, this is f2 star of t plus tau dt whole conjugate. So this is equal to limit t tends to infinity 1 by t integral minus t by 2 to t by 2. This becomes f1 star of t and this is f2 of t plus tau dt. So when we replace tau equal to minus tau in this equation, so limit t tends to infinity 1 by t integral minus t by 2 t by 2. This is f1 star of t and this is f2 of t minus tau, and this is equal to dt. Now this is equal to R21 star of minus tau, and come to the next property, R12 of tau is not equal to R21 of minus tau unless correlation convolution is commutative here. So R12 of tau is equal to 1 limit t tends to infinity 1 by t integral minus t by 2 to t by 2 this is x1 of t, this is x2 star of t plus tau dt. Now replacing this one, this is suppose r21 of tau, so limit t tends to infinity 1 by t integral minus t by 2 to t by 2, this is x2 of t, this is x1 star of t minus tau dt. So replacing r2 1 of minus tau in this equation, this is limit t tends to infinity 1 by t integral minus t by 2 to t by 2, this is x2 of t and this is x1 star of t plus tau dt. So from this we can understand that r12 of tau is not equal to r21 of minus tau. So coming to the next property, this is third property, r12 of tau value equal to 0 at tau equal to 0 if x1 of t and x2 of t are orthogonal functions. So r12 of tau is equal to limit t tends to infinity 1 by t integral minus t by 2 to t by 2, this is x1 of t, this is x2 star of t plus tau dt. By substituting tau equal to 0, this becomes r12 of tau, that is nothing but r12 of 0, which is nothing but limit t tends to infinity 1 by t integral minus t by 2 to t by 2, this is x1 of t and this is x2 star of t dt. So statement of orthogonality, whenever two functions are said to be orthogonal, their product and integrated over any time period will be equal to 0. So therefore r12 of 0 is nothing but 0 if x1 of t and x2 of t are orthogonal functions. And coming to the fourth property, r12 of tau, r12 of tau will have the Fourier transform x1 of j omega into x2 star of j omega. So this is r12 of tau is nothing but limit t tends to infinity 1 by t integral minus t by 2 to t by 2. This is x1 of t and this is x2 star of t plus tau dt. And similarly, this is t tends to infinity 1 by t integral minus t by 2 to t by 2. This is x1 of x1 of t minus tau into x2 star of t dt. So Fourier transform of r12 of tau is equal to integral minus infinity to plus infinity r12 of tau e power minus j omega tau d tau. Substitute in this equation. So this is equal to integral minus infinity to plus infinity. What is r1 of tau? r12 of tau. Limit t tends to infinity 1 by t integral minus t by 2 to t by 2. This is x1 of t minus tau into x2 star of t dt and e power minus j omega tau d tau. This whole thing is R12 of tau. So now let t minus tau is equal to L and tau is equal to L plus t. D tau is equal to dl. Okay, now integral minus infinity to plus infinity, limit t tends to infinity 1 by t, integral minus t by 2 to t by 2. This is x1 of L into x2 star of t dt e power minus j omega L plus t dl. Now this is equal to integral minus infinity to plus infinity x1 L into e power minus j omega L dl into integral minus infinity to plus infinity x2 star of t e power minus j omega t dt. So this is nothing but x1 of j omega into x2 star of j omega. So from this R12 of tau will have Fourier transform x1 of j omega and x2 star of j omega.